I'm Melissa.
I'm Jam.
And I'm a chemist.
And I'm not.
And welcome to Chemistry for Your Life.
The podcast helps you understand the chemistry of your everyday life.
Okay, so today's episode is in response, I mentioned it last time, to a request from Samwise on Instagram. She asked us if there's any chemistry to lightning.
And we told her, no, sorry, no chemistry.
We told her even if there was, we hate chemistry.
Yeah, you could not pay us to talk about chemistry.
You could actually, though, if you wanted to. You can go to ko-fi. I'm just kidding. Okay, so we're going to talk all about the chemistry of lightning. And of course, there is so much chemistry in lightning. You want to know why?
Yeah, I guess I do.
It's because lightning is essentially a discharge of electricity. And do you know what electricity is?
Is it chemistry?
It's a flow of electric charge, which comes from
chemistry.
Electrons.
Good try. Electrons.
Well, I do have...
Which we actually talked about in the batteries episode.
Yes, and I do have written here, electricity is a flow of electric charge, and charge comes from chemistry. So technically, you said exactly what
was written. Yeah.
But I said gaining or losing electrons is what makes things charged.
Right.
So all electricity comes from the movement of electrical charge, which is the movement of electrons, essentially.
Okay.
And in case you can't remember which one is negative or positive, I always remember the joke my cousin Sarah told me in the 10th grade, which was, and Adam runs into a bar and says, I think I lost an electron. And the bartender says, are you positive? That's how I remember. If you lose electrons, you're positive. If you gain electrons, you're negative.
Right.
So lightning is just a big electrical charge that happens in nature, and it's all about the flow of electrons.
Okay.
But obviously, it's a little bit more complicated as to why charge even kind of happens in nature.
Right. Why is there so much charge up there in the sky?
Yes.
And why is it in the first place? And then what makes it come out?
Right. Those are all great questions. That's what we're going to talk about today.
Oh, good.
But
okay.
Also, though, I will say this gets into kind of a place, again, where this science is gray. So there is some understanding of what causes the charge to happen and why it discharges, but there's not a very clear understanding on the deeper level.
Got it.
So, and I saw a few different papers cited, so we'll talk all about that. Okay, so 2 weeks ago, when we talked about clouds, we talked about how clouds are a bunch of suspended water droplets in the air.
Mm-hmm.
Well, sometimes it's so cold up at that part of the atmosphere that there's actually frozen water as well. We didn't talk extensively about that.
Okay.
But there is sometimes frozen water in the clouds because it's really cold up there.
Mm-hmm.
And ice is less dense than water.
Right.
Which means it will kind of rise to the top of the cloud, and then the heavier actual water will go to the bottom.
Okay.
And as they're moving, as they're jostling around to get from the bottom to the top and vice versa, they'll bump into each other and electrons are transferred.
Okay.
And typically, the solid ice, which is more crystalline and more light, will go up to the top, and it's going to lose electrons and become positively charged.
Okay.
And the water droplets on the bottom, the heavier ones, are going to be gaining the electrons that the ice loses, and those are going to be more negative.
Okay.
What I couldn't find was why that happened.
Interesting.
So I looked, and I'm hoping, I reached out to that meteorologist. He reached back out to me. Hopefully we'll be able to connect with him.
Okay.
I'm hoping he will be able to clarify that, but I think from the papers I found, it's not incredibly clear. I found one that suggested it was from like Equilibrium, but it was in a preprint, which means it wasn't peer reviewed and accepted. So I don't know if it ever even became peer reviewed and accepted.
Right.
There is a lot of laboratory data, though, that suggests that when the ice crystals sort of collide with the water, there is this precipitation charging. And that's why we know that it happens, but I don't think there's a clear answer as to why that charge transfer happens when they collide. And that's kind of as far as I could get into it. I could not elucidate it anymore.
Interesting.
I know, and kind of annoying.
Yeah. But I guess in some sense, like, I could see the difficulty. I can sympathize with the people trying to study this stuff and be like, okay,
Right.
the clouds are way up there.
Right.
And we can't quite get inside them and tinker around.
Well, I do think they tried to. I think there was a lab that recreated these conditions and observed
okay.
it.
Got it.
A lot of this work came from this person named Dr. Clive Saunders.
Mm-hmm.
He actually wrote the Encyclopedia of Weather and Climate Change, and he did a lot of research. And my understanding was that he recreated the conditions in his lab to observe the charge transfer happening.
Mm-hmm.
But I don't think he could do the why. I don't think we ever came on the why.
Right.
That was the thing that I couldn't get to. It seemed as if there was a clear, this does happen, and it seems to happen at this moment when these particles collide, but I could not find a why.
Huh.
It made me really sad.
Yeah.
I really wanted that answer. It feels a little unsatisfying, but sometimes that's what it is to do research. It's like we're coming in at the unfinished answer, right?
Right.
And we've seen that a lot in Chemistry for Your Life, but this one was very unsatisfying. I really wanted the why. Okay, but we do know that it's happening, right? So these clouds are having particles within them bounce off of each other, and it seems that typically the lighter, more snow-like particles are losing the electrons and they're floating to the top, and the more water heavier ones are gaining electrons and they're falling to the bottom of the cloud. And that means that we have an excess of electrons at the bottom of the cloud and an absence of electrons at the top of the cloud.
Got it.
So there's a big differential. There's an uneven spread of the electrons. There's a ton in one area and not enough at the other side.
Right.
So essentially now you can imagine that this cloud has a negative charge at the bottom. So in your mind, have a little cloud that's negative on the bottom and a positive on the top.
Mm-hmm.
And that's not going to fly.
Mm-hmm. Not in my house.
Not in nature. Nature hates it when there's a big uneven thing, and it will do whatever it can to sort of even it out. Has been my experience.
Right. Nature is one strict master, one strict mama.
Yes. And so the mismatch is going to correct itself. And when that happens, we have lightning. And normally that happens within the cloud itself.
Okay.
So think about lightning that you see that seems like sort of flashes up in the air and it doesn't come down to the ground.
Yes.
That's clouds within themselves or with a cloud next to them correcting the charge mismatch.
Okay.
So the charge separate starts to happen. There's a negative at the bottom. There's a positive at the top. They'll find a way to connect to each other, create a channel of electrons, and boom, big flash of light. And you're literally watching a row of electrons go back to where they want to go and even the charge back out in the cloud.
Got it. So when we see clouds, obviously we often see clouds that are not doing this.
Right.
Does that mean that the process is still happening and the difference of the one part of the cloud having too many electrons, one part of the cloud having too few, has not gotten significant enough yet?
Yeah, probably. As thunderstorms are building, you mean?
Yes. So
yes.
basically,
yeah.
We see clouds all the time, even big ones, but they're fine. They're not trying to correct their...
Yes, and I think, although I don't know for sure, I think it has to be just the right conditions to where you do get that ice. They sometimes call it graupel, like Graupel, but where you get the ice colliding with the water. And I think you have to have like a certain maybe height, or it has to be at the certain part of the atmosphere to where you get that sort of...
Got it.
That all those conditions. I think a lot of times what we see is clouds that are really small that are floating around, or, but it just hasn't gotten to the proper height or hasn't gotten to the proper, wherever the atmosphere gets cold enough for there to be ice water colliding.
Right.
I don't know all about I'm not a meteorology expert.
Conditions have to be right for the ice to be forming and for the charge to start kind of happening and stuff.
Right.
Okay, got it.
So if we're not seeing lightning, that means that we're probably not seeing clouds that have a strong differential electrons.
Okay.
Okay, but sometimes what will happen is all the negative charge in the cloud will descend from the bottom of the cloud to the earth. And I'm actually going to quote the National Weather Service because they have a really good explanation. It's linked in our references, and there's a really good picture that goes with it to explain kind of how this happens.
Okay.
So you have this negative charge at the bottom of the cloud, and a channel of negative charge called a stepped ladder starts to descend from the bottom of the storm towards the ground.
Mm-hmm.
And we can't see that, right? But it starts to shoot to the ground in a series of rapid steps. And each of those occur in less time than it takes you to blink your eye. And as the negative leader approaches the ground, positive charges begin to collect in the ground. So it's like negative electrons are moving towards the ground in a channel, and that strong negative force is bringing positive. Well, I guess bringing positive towards it isn't exactly right. It's pushing away other electrons. They're repelling each other, meaning that a positive charge is forming right there on the ground. And that was a sidebar. I'll go back to my quote now. As the negative leader approaches the ground, positive charge collects right there in the ground and in objects on the ground. And when this positive charge sort of starts to form, it'll reach out to the approaching negative charge with its own channel called a streamer. So sidebar again, essentially negative charges are starting to come down from the cloud, causing almost an induced positive charge to then be pulled up from the ground. So the negative charge reaching down is the stepped ladder, and the positive charge reaching up is called a streamer.
Mm-hmm.
And when the stepped ladder hits the streamer, that's lightning.
Okay.
So I'll read back into their quote. When these channels connect, the resulting electrical transfer is what we see as cloud to ground lightning. After the initial lightning stroke, if enough charge is left over, additional lightning strokes will use the same channel and give the bolt a flickering appearance. So the initial channel forming is invisible, but as soon as those two channels connect, that's when we see lightning, and then that same channel may be used multiple times, and that's when we get the flicker of lightning.
Got it.
And that's lightning.
Whoa. That is so weird. I mean, one, the invisible aspect of that is weird and trippy.
Yeah. And also scary because you could be the positive thing. If you're about to get struck by lightning, positive charges could be collecting in your body. Right.
Dang, that is so strange. It also, in a way, feels a lot more understandable, even though there's still so many mysteries to that.
Right.
It's like most of us often think of like, oh yeah, these things that are natural, but that can cause disasters of some kind of cause fires or can injure people or whatever. They seem so random or whatever. It's like, well, it is and it isn't. I mean, it's like this thing is charging up. It's going to hit something. It's going to get something. It's got to balance out somehow.
Right. And it can either balance out with itself at the other part of the cloud, or it can come to the ground.
Yeah.
And I assume it just depends on the conditions of which one's easier for the electrons to get to.
Yes. It's almost like, so I feel like this is somewhat relatable for most of us. It's almost like if somebody was standing in front of you and had a rubber band, and they were pulling it back, eventually that rubber band is going to snap in some way and go back to what it wants to be, right?
Yes.
We'll go back to some sort of equilibrium or whatever.
Yes.
When it breaks, though, it could go any number of directions. It could fly at you and hit you in the face.
Fly
back at the person who's stretching it, hit them in the face, go some other random direction.
Yes.
But the more and more that tension is growing, it's like you've got a thing that's going to snap in some way. And it's just a matter of time.
Yeah.
Or whatever.
And I think another thing that's interesting, if you think about it, is what you're seeing with lightning is literally electrons moving. I mean, you don't see the initial channel, but you're seeing all the energy that forms from that rapid movement of electrons.
So because of that movement, it goes into like a visible range of
I think it's the energy that's
The
the
energy
visible. Yeah.
is energy is in a visible range of light for us.
The energy that comes from the movement of the electrons.
Wow. That is so weird.
So weird.
We're like just seeing energy.
You're just seeing energy and you're seeing electrons move around, kind of.
Yeah. That is
weird, right?
So weird.
And also amazing.
Yeah.
And the idea of it when it's reaching out to the ground, it's so many analogies kind of at once, but it's almost like a magnet where, you know, when you push a negative magnet towards another negative, it'll repel it. So you're repelling the negative charges away in the ground to make a positive concentration. And then that positive concentration is like, wait, I want a negative. So then it reminds me of like Sistine Chapel. Is it Sistine Chapel with the touch? Is it Michelangelo's painting?
Yes.
So then it kind of reminds me of that, where it's like, okay, so the negative charge is he touching God's hand? Is that what that is? Okay. So the negative charge is God's hand, and then is it Adam?
Yes.
And they're coming together, and then like when they touch, the light happens, right? So that's kind of what we're actually seeing happen is, but God's finger and Adam's finger are invisible.
Yeah.
And then the light is the only thing that we see actually happening.
That's interesting. I have seen that painting, by the way, in real life. I've been to the Vatican.
Where is that? In the Vatican. Okay, yeah.
And you can't take pictures of it. That's one thing that you'll find out fast. It's also crazy how much more of that painting there is. That's obviously the focal point.
Right.
But there's all this other stuff, and it's actually kind of small. And you can kind of like look around and be like, wait, where are they again? Like I thought it'd be massive because all the pictures I have seen have like zoomed in on that.
Yeah.
But anyway, I love that. I love that visual picture of God and Adam touching. And it's such an iconic, everybody knows it. You know,
everybody knows that for sure. Yeah, so that is lightning. You're watching electrons transfer that charge to neutralize out the positive and negative buildup.
Dang.
And I did read some about, and I didn't quite understand this, so I didn't want to go too in depth, but also it helps to neutralize any differentials in the atmosphere. Like it helps regulate. Thunderstorms help regulate our atmosphere if there's any charges that shouldn't be there.
Interesting.
I know. I was like, what? And then I didn't have time to finish.
Because of the lightning.
Yeah, I think so, yeah.
Is basically correcting the differential in the cloud. It also, but at the same time, just...
I would think if there's like a positive pocket or a negative pocket, the electrons that have built up in the cloud can help fix that. But I didn't know where that came from, and I saw one line about it and couldn't really find anything else, and then I left it alone.
Interesting.
I know. But it looks like thunderstorms might have some regulatory effect as well.
Dang.
Weird.
That is so strange.
Well, you kind of already gave me a explain it back.
I did. Maybe I'll just run the basic chemistry back by you to make sure I get it.
Yeah, do that.
The rubber band analogy kind of works, but not like fully. And so let me just make sure I'm not misunderstanding something.
And I'll enjoy this coffee you made me while you do that.
Yes. So we have clouds that in the certain conditions start having ice form in them. Very tiny ice crystals.
Yeah.
And because ice, once water becomes ice, is actually a little bit less dense than when it's in liquid form. The ice crystals want to slowly move their way up to the top of the cloud.
Yes.
Because less dense. And the water wants to move its way down to the bottom of the cloud. And through that process, somehow they are bumping into each other and all this stuff. This massive cloud is happening on this massive scale. All kinds of electrons from the ice start being somehow taken by the water.
Yeah. And I would imagine it'd be sort of a 1-to-1 ratio, although I don't know. But in my mind, I was imagining like a water molecule hits an ice molecule or a collection of them, and it takes an electron, and then the water takes an electron, and then it starts to move on its way.
Yeah.
And it might hit a lot of other things and then gain an electron, lose an electron, it might just be going back and forth, but it happens on a large enough scale to where there's a net gain and loss.
Yes. And that reminds me of what you said in the episode about clouds existing in the first place, is how much water is in them. Like, this millions of pounds or whatever. I can't remember what
it was a huge number.
Yeah.
I just re-listened for edits and I don't remember.
But just so that's the scale we're talking about. It's massive.
Right.
So even if it would seem like, oh, it's a small thing, it's happening to tons of water molecules, tons of ice crystals across this massive thing floating in the air. Mm-hmm. And then eventually it gets really bad. The bottom of the cloud, the bottom half where the water's kind of hanging out, is very, very negative. It has
lots of electrons,
way more than it should have in a normal situation.
Right.
And the ice at the top is lacking a lot of electrons that it should have. Mm-hmm. It is very positive, and in a way that would not normally occur and should not be.
Yes.
And nature wants to balance the scales. And things getting that out of whack, when they get back to being balanced, they bounce with a bang and a crash.
Yes, that's right. And we're actually going to talk about that also again in 2 weeks when it comes to wind.
Ooh.
Nature's, I don't know if I can always say nature's trying to balance, but a lot of times in chemistry, things are trying to even themselves out, is what a pattern I've noticed.
Interesting. True justice, you know? Just nature is a blind justice. Okay, so
what's the thing where everything's equally shared? Socialism?
Yeah, or communism. I can't remember which one's which, socialism or communism. One's the
nature's trying to share all the resources equally.
Right. Yeah, at the molecular level.
At the molecular level, yeah. Right. In other ways, it's not. But at the molecular level, electrons are trying to get to even environments.
Yes. Unfortunately, nature does not care about us having equal things with each other.
That's true.
For better, for worse, whatever.
And human nature is its whole other thing.
Yeah. So that's happening. That needs to correct itself. Sometimes it just corrects itself within the cloud. There's a jump of lots of electrons moving back to this very positive part of the cloud that is lacking tons of electrons. Mm-hmm. So it just goes, and we see as the electrons are moving, we're seeing the energy of them moving.
Mm-hmm. The flash of light.
And that is just whatever you want to call it, intercloud lightning or something.
I think there's a name for it, but I didn't write it down.
And then, so we see that sometimes. We see those little flashes. Sometimes it's kind of like diffused and hidden behind clouds. We also see and worry about the lightning that comes down here.
Yes.
And in some situations, instead of correcting within the cloud itself, it sees fit to
for whatever reason
to correct the imbalance of electrons by using the earth instead, or whatever it can find close by.
As an electrical ground, they call it.
Right, as a ground. And so it starts reaching down toward the earth. And as it's doing that, repels lots of electrons away because it is so heavy with negative electrons. Very, very negative. And so as it reaches down, then there becomes this very positive area that also reaches up to meet it, which is interesting. God and Adam touching fingers. And then, boom, now there's a highway for these electrons to move. And then we start seeing the energy.
Yes.
That's because the electrons are actually able to move. The floodgate has been opened.
Yep.
And they can go freely.
Yes.
And because of that, also happens the opposite way, too, where it can be like a down, then an up, and then a down or something. We see some flickers of various...
I think it's mostly down. It's just this, like... oh, these electrons in this part of the cloud found a channel, and then more use that same channel, and more use that same channel, I think.
Okay.
But it also, while it's negative electrons moving, also equal out the positive in the other place, right? So it kind of evens out.
Right.
That's a good one.
And there's lightning.
I try to think of an analogy for negative people, like building up and starting a riot, but then I couldn't really think how everyone neutralized back down. And usually it's not as these people became angrier and angrier, these people become happier and happier.
Right.
Maybe like the French Revolution or something. Like, these people are richer and richer, and these people are poor and poorer, and then they get mad, and so they reach out.
Yeah.
But the rich people aren't reaching back.
Right.
Right. So
there's very limited analogies for the negativity and positivity of people.
Yeah.
But yeah, that's interesting.
So there's a buildup of negativity that depends on the positivity of these other people, and then a force happens and neutralizes everyone out, so everyone's satisfied. But I don't. Yeah. Hard to think about what a good analogy for that could be. But I kept thinking of the Sistine Chapel.
Okay, how about this? So let's forget about negativity and positivity for a second.
Okay.
Because it also makes it hard because you're sort of picking a side in terms of like a conflict or war or whatever. So pretend it's just a war.
Okay.
There are two groups of people.
Okay.
They are both becoming more and more polarized.
Oh,
you know,
okay.
Regardless of which is good or bad.
Yes.
The people over here are getting more and more alike in this way and stronger in their feeling
Toward
about
their
this.
cause.
Yes.
Say their cause is negativity.
Yes. And then so is the same with the positive side over there.
Okay, they're getting more and more polarized to their positive side.
And the more and more they polarized, there's going to have to be a correction. It's building.
Yes.
And then when there is, it's a fight. It's a big brawl. It's a loud, thunderous
huge
thing.
Huge display of energy. Huge
Yes.
exertion of energy.
Yes. And if it never got that bad, it wouldn't happen that way, right?
Right.
If it was like just a little kind of thing, it might correct itself in a small way.
Right.
Just a few molecules getting a little
right.
polarized, bounce back, and there's no huge thunderstrike. Does that work?
I think that does work. The only problem is after the huge expansion of energy, I don't know that people neutralize.
Right.
In wars, usually somebody wins.
Right. Somebody wins. That's a good point.
So that makes it hard. But I do agree, like if there's a small scale where a few electrons are transferred, it would not cause the big fight or the big lightning. So just hard because
maybe there's a war we could look up if we really wanted to, where there were two different sides, and the time where they came back to equilibrium was like a pretty good treaty that was like pretty mutual. You know?
The Christmas thing that happened in the trenches.
Oh yes, okay, yes.
There we go. We'll just
I forget what war that was.
But we'll pretend it stopped right there. The war never happened again after Christmas.
Yeah.
So they were polarized, and they had this huge thing of energy, and then they're like, okay, it's Christmas, we'll stop.
And then it was equilibrium, neutralized.
And then we'll pretend the war ended right there.
Yes, yes. I'm sure there are wars like that we could look at.
I'm sure.
I
don't know a ton about history, although I think history is really interesting.
Yeah. There's got to be some treaty somewhere where it was like, oh, I gave equal amount of whatever, and you gave equal amount of whatever, and we're all happy.
Yes.
And now we're coming back to this, mixture of electrons are evenly distributed or whatever.
Yes. I just thought of an analogy that would be really good, but actually I'm using it for the next episode, so I can't share it with you.
Okay, hold on to
it. So sorry. Okay, well, that's it. Good job on the lightning front.
That was so interesting, dude. I love these. I love the weather stuff, so I'm excited about the next one as well, but these have been really interesting to me.
They have really been, and you've earned some fun and then also some less fun facts.
Okay.
So one fun fact is that lightning has so much energy that it's hotter than the surface of the sun.
Oh my gosh.
It can be up to 50,000 degrees Fahrenheit.
Jeez, I had no idea.
It can also strike up to 10 miles away from the storm.
Wow.
So if you can hear thunder, you are in danger, even if you don't necessarily see the lightning or you think the storm is far away.
Okay.
Okay, and then also, many people die of lightning strikes every year.
How many? What did you say?
It kills about 20 victims a year, but hundreds more are injured.
Dang.
And some suffer lifelong neurological damage.
Yikes. Makes sense. I mean, it's like way more energy and charge going through a person than should.
Yeah.
So
I don't know. I think it was a podcast called This Is Actually Happening, where they kind of like interview people as they're experiencing things that you feel like will never happen.
Uh-huh.
And I think they interviewed someone whose child died of a lightning strike at a park.
Gosh.
So it is real. It does happen. I remember thinking my mom was kind of paranoid, and I was like, it's fine. But no, it's really not fine.
Yeah.
So when there is a lightning storm, if you can't get inside, you want to try to get in low-lying ground, because that channel, the finger reaching out, will try to happen from the highest point usually. And so you don't want to be the highest point.
Right, right.
And you should also avoid tall trees and metal that will conduct the electricity.
Okay.
So that's some lightning safety for you.
Okay.
And then I have a crazy story. Are you ready for it?
Yes.
When I was in elementary school, have you heard this story before?
I don't know.
Okay.
I mean, I did know that you're in elementary school once.
Okay.
So.
So when I was 6 years old, It was the year Anastasia came out.
Oh, yeah.
My family was going to go watch Anastasia in the movie theaters, and my dad was leaning up against our fireplace that had a metal grate that kind of like, it was a metal grate that went up the chimney.
Uh-huh.
And it was a thunderstorm, and a finger of lightning, so not the whole bolt, but a finger that came off of it, hit our chimney and traveled down into my dad's body, and he flew across the room.
Oh my gosh.
And it was crazy. My dad got struck by lightning inside the house.
Oh my gosh. So many things had to like line up for that to happen.
know.
He had to be leaning against that. There had to be like something conducting it through.
Yep.
Jeez.
And he flew across the room.
Yeah.
And we didn't go see Anastasia.
Yeah.
I don't remember ever when I did see it. Eventually I did.
Yeah.
But he had to go to the hospital, and there was like a picture of my sister on the newspaper crying. It was like this whole thing. Yeah. And so
the news. You're in crisis. Can I take a picture of you?
I know, seriously.
Oh gosh.
And she was like, if I was 6, she was like 11. So that's crazy. But there was a mark on him where it like entered his body, and then that faded away. It was like a pattern of like, I guess there's a common pattern that lightning can kind of leave behind. And then that faded away, and he was totally fine because it was such a small amount, because it was like a finger that traveled down instead of the whole bolt didn't hit.
Yeah.
So.
Wow. Gosh, dude.
I know my dad is a survivor of lightning strike, but I didn't know until, I was a lot older how lucky he was, like how bad it could have been. And
Seriously.
So I try to like not take showers when it's stormy and all these things, because I have experienced something really crazy like that happening. So
I wonder if like, that makes me just think about the potential value of some sort of lightning rod on homes, to be like, okay, please hit here instead of somewhere else nearby.
Or just being careful about, there's probably not a lot of surfaces that are metal that go straight from the outside of your house to the inside of your house, but the chimney happened to have that,
Totally, yeah.
So there you go. That's my 1 in a million story.
Dang. That is insane.
My dad got struck by lightning inside the house.
Yikes.
And I never got to see Anastasia. I mean, I did eventually, but I didn't that day.
Yeah.
So it was December 23rd. We would always go see a movie on December 23rd.
Oh, nice.
So it's weird that I have that. Those were the big deals to me as a kid, that I could like, I knew we always saw a movie that day. And,
Yeah. Very memorable, weird day, I'm sure. Gosh dang.
So I saw my dad fly across the room from lightning, which, think about that. Like, that's how powerful it was. Even though he was fine.
Yeah.
It literally threw him across the living room. Like, from his one spot on his shoulder where he was leaning up against a grate, he flew across the living room.
Yeah.
A grown man.
Yeah.
That's so much energy.
Yeah, really. It's so crazy, too, because like, I've heard those kinds of things in lightning strike stories. Not that I've heard a ton, but like people like flying across the room with their shoes flying off, something like that.
Right.
And it's just I believe it, but it's so hard to imagine. Like I'm like, I just don't understand it. It's clearly this force of nature that we can't really make sense of, even if we try to understand the science of it. It's still just like, oh yeah, but it's gonna do like really weird things, like throw somebody across the room or blow somebody's shoes like 100 feet away or something like that.
It's so much energy, yeah.
Yeah. Jeez.
So that's my lightning story.
I don't have one, unfortunately.
That's good. No, that's fortunate. That's a fortunate thing. That's not unfortunate. But do you have any other stories? Maybe a weekend recap story?
Yes.
Because those are all counted as fun facts, so we still get to talk about our lives separate from that.
Okay. Wait, so you get to also? So you get to share a story from your life and... Oh,
sorry.
Wow.
That's the way the cookie crumbles. You didn't have anyone suffer from lightning.
That's true. Okay.
Count your blessings, Jam. I get 2 stories, but you know.
That's true.
I'll keep mine short for fairness sake.
Okay. Well, I have something to share that's very on brand with this episode. So I've been doing some electrical stuff.
Oh, I didn't know that.
In our house. I've been doing it as safely as I possibly can. This is the kind of thing that you got to give caveats, like don't just do stuff at home. Like talk to people who are smarter than you, give recommendations, take all the precautions or whatever, blah, blah, blah. Everything I'm about to say after this, don't forget that I said be careful and don't do this stuff if you don't know what you're doing.
Definitely.
So I have been adding some lights into our house.
Wow.
And I just got determined and inspired because I was like watching some videos about it and reading some stuff about it and was like, I think I can do this. Something about the way lights and circuits and stuff work just started to click for me and make sense.
Wow.
Not in every single way. Like I don't understand everything. I'm not an electrician, but simple stuff like adding a light to a circuit that's already there.
Yeah.
So just there's already a light on one circuit. I don't add another one.
Right.
Stuff that's pretty simple. That's pretty doable at home. And so I added one above our guest shower, which is pretty dark in there.
Yeah.
And I did that one. I was really not sure if it was going to work. I did all this stuff. I had the breakers off and stuff. And then I did this all at like late at night while my son was asleep, and then was very surprised when I turned the breaker back on and turned the switch on, and it worked.
So yay! That's cool.
So then I was like, okay, one challenge accepted and completed and succeeded. So why don't I add 2 lights to our bathroom? So I added one above our toilet.
Wow.
And above our shower.
So you made the hole in the ceiling. You put the thing that accepts the light bulb in there with all of its wires, and you put the fixture on too. Yes.
Now I will say I use these
put
really
the light bulb in.
Exactly. I use these really cool. I mean, it's not super new, but relatively new. Really low profile LED light things that are recessed lights. So there's a lot of things that make it easier about that because they actually have this way of staying in the drywall. You don't have to like add a box and screw it into one of the studs in the ceiling and stuff like that. They have this way of clipping it really securely onto the drywall without pulling too much down on it.
Oh, that's nice.
And so that makes it easier for sure.
Yeah.
So, but yes, exactly what you explained. In our bathroom, I had to do it twice. I added one light above our toilet, and then from that light, I did some wiring over to another hole I made above our shower and added one there.
Wow.
And now it's like we can see.
Do you feel so powerful?
I do. I feel also the feeling that you feel when you've done something you think you couldn't do and you kind of get addicted to that feeling.
I remember the first time, this is so weird, but the blinds in the room and the house I was renting were just broken and you couldn't like open them or close them. They were always halfway. And I Googled it and found a YouTube video on how you can remove blinds. And it was not straightforward, but I took those blinds out and I was like, I can change things I don't like.
Yes, yes.
And then I started adding hand towel racks and toilet paper racks where I like changed everything. Anything I didn't like, I just fixed it.
Yeah, yeah.
It was amazing.
Such a great feeling.
It really is.
The other things I want to do are going to be more complicated. Like I have to add another switch as well to the next thing I want to do.
Yeah.
And then I want to try to add 4 lights in one of the rooms.
Wow.
And a switch. So that'll be kind of challenging. The room you and I are recording right now, notice there are no lights on the ceiling at all.
Oh my gosh.
That will be the one after that. It'll have to be like each thing is a stepping stone.
How
like,
exciting.
One more difficult. It's like this one I have to add lights where there is no light at all.
But you're going to be able to.
Yes.
I believe in you.
I hope so. So that's what I've been doing. And
that's very cool.
Electricity, electrons. I've just been doing some chemistry.
You really have been. My sister-in-law's boyfriend is studying to be an electrician. And I'm like, in a way, we're both chemists.
Yeah, that is fascinating to me. I love
electricity.
I would love to, in a different life, be an electrician. Sort of like I would love to do it and then come back to my real life.
Right.
Like I'd love to just go experience that for a bit.
Well, and that's something I don't think we've talked about on here, but I don't think that college is always the best option for people.
Totally.
I think a lot of people go to college for skills that they're sort of just going because they just think they should, but then they just get this sort of generalized skill set that's not really helpful in any one area.
Yeah.
I knew I wanted to do chemistry, so that was easier for me.
Right.
Although I did think I wanted to do neuroscience for a while. But if you aren't sure and you have a passion for something like plumbing or electricity or cars, going to a trade school where you can learn that trade is actually you would probably spend less on schooling and earn more very rapidly. And you're in a job that is almost always going to be in demand unless the whole society as we know it falls apart.
Yeah.
And yeah, you can make a very good living off of that. And it might be useful after you've gained that skill to go back to school for an MBA so you can have a business.
Yeah.
But learning those skills is really, really important. And not very many people see that as an option. But that is a very good option for a long-term career.
Yeah. Yeah.
Highly recommend.
Yeah.
And you can build over time your skill set and then start managing people and then have a business. And you can sort of transition into a manager role by the time that you are ready to be not on your feet all the time as an older person.
Yeah.
So strongly recommend.
Yes, definitely. So that was my thing of the week. Just try and top that. I'm just kidding.
I can't top that.
I'm just kidding.
But I will say my husband's family has that same thing where they just fix things they don't like. And actually his grandfather-in-law built like a whole tower on a house. There's a house where they used to live in Amarillo that has like it almost looks like a turret in the back. It's not huge, but it just sort of sticks up above the house. And they just changed it to make the master bathroom on the bottom floor big and then put a little bedroom on top, up like spiral staircase.
Wow.
I know. And I'm like, wait, you know someone who built that part of a house? That's incredible to me. And he remodeled their whole home they're in now. And his dad, before he passed away, it was like that. And actually, that's a good transition into my thing, which is that my husband's dad, a lot of you don't know, I didn't talk about it very much on air, but he passed away right after we got married about a year ago. And we needed to go through some of his stuff. So we went over to my husband's grandparents' house, which is, it's sort of always like a big family affair type thing where his grandmother's there and her husband, who they've been married a really long time. So that was kind of like Mason's grandpa growing up.
Yeah.
And her daughter and their kids. It's just like, and her partner. And there's just like everybody and their partners are all there. And it's just a huge, big party kind of.
Yeah.
And his family came into town from Amarillo, his immediate family, sister, brother, their partners. It was just like everybody was there. And his mom even stayed an extra day and just hung out at the house with us. But it was just really nice to see everybody. And again, it's sort of like going back to what I said on the last episode. I'm getting back into being a person.
Yeah.
And so he's been over there several times without me to do things because I was just working all the time, you know, and it was just really nice to get to connect with family and reminisce and hear stories about his dad, who I actually wasn't ever able to meet. Weirdly, we both lost a parent at a really young age and we weren't ever able to meet either of them. So it was nice to learn about some qualities that Mason shares with him. And so, yeah, it was a good weekend.
Yeah.
It was bittersweet, sad at times, but nice to get to be with everyone. Yeah. And his dad would have really loved that. He loved being with the family. So,
dang, dude, that's very cool. Yeah. I mean, sad, but good that there can be sweet moments.
Right.
When you come together like that, and there can be really good family time and stuff. So I know exactly what you mean.
Good food together.
Yes.
Yeah.
That's cool.
And we always go to Hot Pot when they come into town. We love Hot Pot. So
nice.
Yeah, it was a good weekend.
Nice.
Awesome. Well, so thanks for that good segue, Jam. You set it up perfectly for me. And thanks to all of you listeners, especially Samwise, who came up with this episode idea. We literally could not do it without you. And it's so fun that we get to come here every week and share a little chemistry lesson.
And thank you for teaching us, especially things that are so fascinating and confusing and things we all wondered ever since we're kids. I mean, we've all wondered about lightning. So thanks for teaching us. And if you have an idea like Samwise did about a question in the world you think might be chemistry, please reach out to us on Gmail, Twitter, Instagram, or Facebook at Chem for Your Life. That's Chem, F-O-R, Your Life, to share your thoughts and ideas. If you'd like to help us keep our show going and contribute to cover the costs of making it, go to ko-fi.com/Chem for Your Life, or tap the link in our show notes and donate the cost of a cup of coffee. If you're not able to donate, you can still help us by subscribing on your favorite podcast app and rating and writing a review on Apple Podcasts. That also helps us to share chemistry with even more people.
This episode of Chemistry for Your Life was created by Melissa Collini and Jam Robinson. References for this episode can be found in our show notes or on our website. Jam Robinson is our producer, and we'd like to give a special thanks to V. Garza and S. Navarro, who reviewed this episode.